In this video, we're going to go over the communicate questions on page 122. So if you didn't get a chance to do the work on it right before this, you can review the video and answer the questions for this. Now, just remember for, I believe it was question or part 4, on each of those, you were supposed to draw a circuit, a circuit diagram for each the series light and the parallel lights. Make sure that when you draw it, you check the pages. It should look very similar to the diagrams that are in your book. Question 1. Now that you have completed the experiments and read the Think Again section, explain why the light bulb went off when you unscrewed one of the light bulbs in the series circuit. Step 8 of the series circuit procedure. Why did a light bulb stay on when you unscrewed the other light bulb in the parallel circuit? Step 6 of the parallel circuit procedure. Now remember, in my demonstration, it wasn't unscrewed. I just used a different light with the bulb taken out of it. So that's going to take the place of the ones that were unscrewed. So when one bulb was unhooked in the series circuit, there was no longer a complete path for the electricity. When one bulb was unhooked in the parallel circuit, there was still a complete path between the battery and the second light. Question 2. How are series and parallel circuits the same? How are they different? Give examples. The two types of circuits still require the same equipment, battery, wires, bulbs, and involve the same energy transformations and require a complete path for the bulb to light. In a series circuit, removing one of the bulbs causes the other bulb to go out. In contrast, you can remove one light bulb in a parallel circuit and the bulb stays on. Two bulbs connected in a series circuit shine less brightly than two bulbs connected in a parallel circuit. And yeah, we did observe that in our work on it video. Okay, question 3. Make a list of other materials that could take place of the light bulb in this investigation. There's lots of different things you can use. A little buzzer, little heating cord. There's lots of different things you could use. Fan, motor, TV, if you had a low enough powered one. A good one would be a doorbell. Question number 4. Describe another situation that has not already been mentioned where a series circuit could be used to operate an electrical device. Okay, so on that, you should think about devices which it's useful to have all the electrical parts on all at once. Something could be like an electric motor, appliance, electric toys, or heating units. On those, you wouldn't want to have a parallel circuit. If one part goes, the whole system would have to stop. Question number 5. Describe another situation that has not already been mentioned where a parallel circuit could be used to operate an electrical device. So you can have numerous examples, but parallel circuits are useful in devices that have more than one load and in which it is useful when one particular load is not working. Something that I'm very happy they have parallel circuits for are the strings of Christmas lights that people put out. If in the old ones, it used to be only on a series circuit, so if you had one bulb out, all of your lights were out. Now they're all set up on parallel circuits, so if one light bulb goes out, all the rest of them are still on. Other things would be like marquee signs, like signs that stores have in front that are lit up. Quite often you'll see one letter burnt out, but you can still see the rest of them. Or light fixtures in a home or school. Imagine if we had one bulb go out in our classroom, we would lose all the lights if it was only on a series circuit.